Hello everyone, welcome back to the fifth lesson that is on complex numbers and DeMoivre's theorem. This is the last lesson in the chapter 8. Now we will see the learning objectives. We will learn to convert complex numbers from rectangular to polar and vice versa, and find products, quotients, powers, and roots of complex numbers in polar form. Now, first, initially, before we go into the objectives, we will learn about complex numbers. Here the key words are complex plane, real axis, imaginary axis, Argand plane. So the pronunciation, there's modulus. Okay, so many. Now, modulus is basically finding the square root. It is, I'm sure you're come across this, these two lines. Now, modulus of 4 would be, that's also called absolute value. Thus, this would be positive 4. So whatever is inside modulus, it'll be just positive. It's the distance. The sign is always positive when you put anything inside these two lines. Now, about Argand plane, this is pronounced as Argand plane or Argand plane. So it's up to you. It depends on, whichever pronunciation you use. So I'll be using Argand plane. And now we will see about the complex. It's also called as complex plane. This guy is the one who found it is Argand, so that's why it's named after his name. Or you can just use complex plane. Now, the complex plane, the details about it is given over here. I'm sure by reading it you will never understand. It's not easy to understand. It's better we see a picture. You can pause the video, read this, or you can read this later on, which will make much sense. Now let's see what exactly it is. This is the complex plane. This will have an imaginary axis and a real axis. Now the real axis is in the horizontal, that's x-axis. Okay, all the real numbers. Now if you remember the complex numbers, you can write them as a real number plus a complex number, right? A complex number is a real number plus imaginary number, right? So this plus, say, 2i. Okay, that's already there. Let me take something else. 4i. Okay. So now this is the real part. So real numbers are just real numbers, the counting numbers which you use 1, 2, 3, 4, 5. Imaginary numbers are all numbers with I. If you have both of them together, it becomes complex numbers. How do we represent it? It is through the Argand diagram or Argand plane or complex plane. Here, imagine this number 3 is somewhere over here. This is the thing. That is the real axis, okay? Now, 4 is in the imaginary axis over here. Let's see where it meets. This is the point. So this would denote complex number 3 plus 4i. That is what this complex plane is about. So whatever the numbers are on the x-axis is real and the imaginary is on y-axis. So now look at this. This is the real and this is imaginary part. So let's solve a couple of problems about it. But before that, let's see about absolute value or modulus. See now, this modulus basically is the distance. Look over here. Algebraically, it's given like this. You might remember distance formula is similar to it. The distance from the center, that is 0, 0, is used. So you will have a plus bi. This is the complex number, right? The coefficient a, square root of that, plus the b square root, the square of a and plus the square of b, the whole square root. So that is what we are doing. It basically gives us a distance from the origin in the complex plane. Okay, so now imagine 3 plus 4i is over here. So the distance, that is square root of 3 square plus 4 square, you'll get something that's 5. That's the distance. That point is 5 units away from 0. I hope this is clear. Now let's see a couple of problems. Graph and graphs and absolute values of complex numbers. Sorry, I was just confused over here. Now, graph each number in the complex plane and find its absolute value. You can see z is equal to 4 plus 3i. Now, this is a complex number. How do we graph them? It's very simple. Identify what is A and what is B. A is the real part, B is the imaginary part. So step 1, write AB values. A is 4, B is 3. Step 2 would be graph the given in the Argand plane. That's over here. If you see 1, 2, 3, 4 x that's the real axis, and 3 in the imaginary axis. You got it. Then you need to find the modulus, that is by the square root. So all you need to do is square root a square, that's 4 square plus 3 square, and that's the answer, that's 5. So that's it. So the absolute value of this is 5. Now similarly, you can try one more problem. The only difference is it's minus numbers over here and minus sign is there. Please pause the video, take time, solve it, and then continue to the explanation. I hope at least few of you tried it. Now let's see the problem. Over here, write A and B values, right? So what do you do is, see what's the A value, that is minus 2. And then over here there's nothing, only minus sign. That means it's minus 1. A is minus 2, B is minus 1. What next? We can graph it easily. It'll be both in the third quadrant because minus and minus. So minus 2 over here and minus 1, this is the point. Now again, find the absolute value. Just make sure when you're finding the absolute value, use brackets because there's negative. So minus 2 the whole square plus, again use bracket, minus 1 the whole square. Okay, this will be square root of 5, that is 2.24 basically. So this is the answer. Once again, I'll just tell you why brackets are very useful. If you don't use brackets, I'll just show you over here, you may not get the correct answer. Minus 2 square minus 1 square. Now over here you will get a math error because inside the square root the negative sign exists and it's an imaginary number, so it won't be solvable. So that's why whenever you are minus, please use square root, which is very crucial, so you will get the correct answer. We saw in a while ago I used square roots and we got the correct answer, but I used the brackets and got the correct answer, but without the brackets you're not getting the correct answer.